It's 9 p.m. at night, and you are hungry. You order a pizza from Domino's. You live on a street that's dark, so you've installed a smart light bulb in front of your mailbox that lights up the address. When the pizza at Domino's is ready, you want the light bulb on your mailbox to light up so that the delivery person can read your address when they arrive in front of your house with the pizza. The internet should make it possible to have this kind of event-driven, connected world. Anything that is connected to the internet should be able to send signals to anything else on the internet so that our lives gradually become more automated. This is what IFTTT does, if this then that, otherwise known as Ifft. Users of Ifft can easily create applets to wire different services together. You can use Ifft to trigger an email whenever 3 of your friends retweet something on Twitter. You could use Ifft to flash the lights in your house when Bitcoin hits new market highs. You can use Ifft to send yourself a pizza whenever Bitcoin crashes. Ifft makes it easy to connect different services together, and a lot of work goes into the infrastructure that enables these billions of events to process correctly. Nicky Leach from Ifft's engineering team joins the show today to describe how Ifft allows for integrations between services that were not built to integrate. And he talks about the scheduling, the data engineering, and the monitoring of the company's software stack. When your application is failing on a user's device, how do you find out about that failure? Raygun lets you see every problem in your software and how to fix it. Raygun brings together crash reporting, real user monitoring, user tracking, and deployment tracking. See every error and crash affecting your users right now. Monitor your deployments to make sure that a release is not impacting users in new, unexpected ways. And track your users through your application to identify the bad experiences that they are having. Go to softwareengineeringdaily.com/Raygun and get a free 14-day trial to try out Raygun and find the errors that are occurring in your applications today. Raygun is used by Microsoft, Slack, and Unity to monitor their customer-facing software. Go to softwareengineeringdaily.com/Raygun and try it out for yourself. Nicky Leach is an engineer with IFTTT, if this then that, otherwise known as Ifft. Nicky, welcome to Software Engineering Daily.
Thanks for having me, Jeff. Excited to be here.
Today we're going to talk about Ifft and the backend infrastructure that powers it. Explain what Ifft does for people who don't know.
Sure. So there are sort of two sides to Ifft. As a consumer, Ifft allows you to connect all the different things in your life and make them work together. And those things might be like connecting your Twitter account to your Facebook account or your connected car to your lights at home. Ifft provides easy functionality for users to build those connections themselves. And then the other side is that we have a platform for companies to integrate with Ifft and provide those integrations for their end users. It's a really easy way to have one sort of integration work with, today, over 550 other services on the platform.
Mm-hmm. There's these two abstractions, service and applet, that people can build on Ifft. What do these two terms mean?
Definitely. So a service is sort of the term that we use to describe either something like an internet service, again, like Twitter, or maybe an internet-connected product like your light bulb or your car or Domino's Pizza. And an applet is sort of a unit of functionality that integrates with one or more different services. So you might have an applet that will post this is sort of like the canonical example, posting your Instagram photos to Twitter directly, as opposed to having just like the Instagram link, which doesn't show up in a lot of Twitter clients. So users turn on individual applets, or they can create their own to create those sort of mappings between different services.
Mm-hmm. Okay. And give a few more examples of services and applets so people can, understand how these different components fit together.
Right. So services are sort of like any sort of brand or property that you might have an association with, again, sort of like on the social side, Twitter, Facebook, Instagram, LinkedIn, in terms of internet-connected devices, like your Hue light bulbs, your LifeX light bulbs. We have a couple sort of like more novel service integrations, like, again, Domino's Pizza. So we have this pizza tracker service where you can see the status of your pizza as it goes through the like preparation and delivery pipeline, and then do different things. So you might have an applet that says, when my pizza's out for delivery, turn on my porch lights.
Mm-hmm. Right. What are some of the apps or applets or services that you use in your everyday life? How does Ifft fit into your daily life?
I'm a total Slack addict, so a lot of my applets are around like curating content in Slack. We use it around the office a lot for things like stand-up reminders and things like that. I also have recently started doing a little bit more of like life cataloging, and a really interesting way to do that is to take different events that you find, like, I guess, like input sources that you find meaningful, and having the output be a calendar. So things like your check-ins on Foursquare or Swarm. We have this awesome location service where you can set up triggers for when you enter or exit given areas, like when I get to work. And having those all end up on a calendar, it really gives you a good sense of sort of like what's going on in your life retrospectively.
Mm-hmm. How has the rise of the voice interfaces affected the Ifft business?
It certainly brought us a number of users. Amazon Alexa is certainly one of the more popular services on the platform. And I think that it's a really natural pairing. Before there were any or even many skills on the Alexa, in the Alexa ecosystem, there were a ton of integrations that you could use with Ifft. I know that when Amazon launched in Europe, Ifft users were just like clamoring to get support in the product. So I think that there's like a natural alignment between sort of, again, that like one-to-many integration that users are able to really apply creativity to and build interesting integrations.
Mm-hmm. Okay, let's start to talk about what's happening on the back end. When I stand up a new service and that service integrates, how does it connect to Ifft's end? Are you standing up an API server for that service, or what exactly is going on?
Definitely. So I think we can sort of answer that question starting historically. 7 years ago, when Ifft was started, all those initial integrations were just built directly into our monolithic application as just like API integrations using different client libraries and things like that. And it didn't take long for us to realize that that just like really doesn't scale in terms of our ability to integrate with like as many services as possible, and also to have like a deep understanding of the best ways for those services to work together. So like really the people who build those services have the best understanding of like the valuable data, what interactions are powerful on their platforms. So about 3 years ago now, we started building the Ifft platform, and the API side of that is what we call the Eff Protocol. And it's really just a standard set of HTTP endpoints that you have to implement to integrate with Ifft. And there's like a schema that basically defines what a trigger should look like, what an action should look like, and a bunch of tooling around making sure that those endpoints actually sort of fill that specification. From sort of a soup to nuts perspective, there are two different ways that partners tend to integrate with the platform. With their Ifft integration being sort of directly inside of their application, you know, sort of like making database calls directly or whatever it might be, or the Ifft integration being sort of like a shim service in between their either public or internal HTTP APIs and the Ifft protocol.
Can you walk me through what happens when someone makes a call to a recipe? So, and I guess we actually have not explored the terminology recipe. We talked about applet. We talked about service. Describe what a recipe is. Maybe you could refresh people on what a service and an applet is while you're doing that. And eventually we'll get to a more detailed description of the back-end architecture. But I just want to give people a really good understanding of what the front end looks like.
Yeah. So I think that thinking about sort of the important Ifft vernacular, services are brands, they're like logos, they're things that you have a relationship with. Applets are specific functionality. Again, like if this then that statements, that's where the name comes from. Applets are sort of a rebrand of a previous concept called recipes. And it was really sort of There's some functional differences, but for the most part, it was sort of a marketing decision. The idea being that, like, we want recipe implies work, right? Like, recipes make baking a cake a lot easier than trying to figure that out on your own, but you still have to go through the steps of baking the cake. Applets, sort of the idea that we want to communicate is that they're little apps that you turn on, and you don't have to do a lot to get that. And then inside of an applet, there's going to be more one triggers and actions. And a trigger is a new piece of data coming into the system. So that might be like you got to a specific location, you posted a tweet, a new entry was created in a database somewhere, and an action is creating content, doing something. So that might be sending a push notification or turning on a light bulb.
The service where I upload a picture to Instagram, and instead of just copy pasting the link to Instagram into Twitter, if you instead wanted to have the picture itself render in the tweet, this is a really common use of Ifft, as you already mentioned. This specific use case of Instagram linking up to Twitter, this would be a recipe. Well, sorry, an applet, formerly called a recipe. And in this example, Twitter and Instagram would both be services, and you're linking together these services with an applet. Have I described that correctly?
That's 100% correct. You did it better than I could have.
Okay. So in calling that recipe, there are some pieces of data that are being passed to the recipe. Where are Twitter and Instagram plugging in and listening for that event, and what pieces of data do they need from that event? Definitely.
So at the most basic level, this is maybe getting a little bit into like how Ifft works behind the scenes. Ifft is calling APIs to check for new data constantly, millions of times a minute, effectively. So in this specific case, like Twitter or Instagram to Twitter, Ifft is polling Instagram's API to say, are there new photos? Did Jeff post a new photo? And when we detect a change, we take that data, package it up into sort of an understandable set of pieces of data we call ingredients that the user can configure to say, like, semantically, this like photo URL, I want that to be the thing that feeds the image that I post to Twitter. So then we do that mapping, and then on the other side of the applet execution, we're sending that data to Twitter using sort of effectively going through the Twitter's public API.
How much volume is coming through Ifft? How many calls to different applets are you getting?
We are on the volume of about 1 billion API calls a month. And most of that, this is sort of like the dirty secret of Ifft, I guess. Most of that is us polling to see if anything has changed. And in almost every case, nothing has changed. So the total volume of API calls that like result in some desired outcome is much lower. But we keep up that volume in order for things to happen as quickly as possible in places where there isn't a real-time integration.
It's unfortunate that you have to do the polling instead of there being some webhook or web task on the providers, on the services end, where they could have their webhook be scanning the event stream, for things that they would want to publish to Ifft. It's kind of unfortunate. It's a lot of wasted effort because of that polling.
So we do have a real-time interface in the protocol. And what that allows our partners to do is let us know that new data is available for us to fetch. Due to a number of circumstances, often just like the functionality not being there in like the origin API, the default behavior is to just poll on regular intervals for that data. But for something like Amazon Alexa, where the latency in that like exchange is so important, they definitely use the real-time API to make sure that that data enters the Ifft system as fast as possible.
Mm-hmm. Okay, so whether the service is sending you the data or you're polling for it, eventually you get notified of some new event, and that happens on a very regular basis. And if I understand the architecture correctly, the first place that the event is going to get registered is in Kafka. Can you describe where the API call is going to begin in your architecture?
So the way that it works today, we do these checks on, I guess it's easier to talk just about the polling interface first,
Okay,
and then we can sort of layer
sure.
on top real time. We perform checks on a per applet basis. So if you have your applet that says, anytime I post a photo to Instagram, post that to Twitter, we enqueue that applet on some schedule that we determine. We can put a pin on that and come back to it. And then once that applet is checked, we make the API call to Instagram, check to see if data is available. And if it is, in line, that goes to the next phase where we post that data to Twitter. So there isn't today a disconnect between like the ingest and like action functionality. That ends up being just like one synchronous or continuous process that happens on an applet by applet basis.
So what role does Kafka play in this architecture?
We currently don't use Kafka. We do use Kinesis. We use it mostly as a tool for like our data and analytics pipelines, as well as some of our other systems where we just need the sort of like a queue of data to be super durable. One of those cases is our activity feed system, where every outcome from an applet being run is output to an activity feed that a user can look at to see, like, did things work? If not, like, what was the failure? Other interesting things around, like, the state of their account go through that same system.
Heptio was founded by two creators of the Kubernetes project to support and advance the open Kubernetes ecosystem. Heptio unleashes the technology-driven enterprise with products that help customers realize the full potential of Kubernetes and transform IT into a business accelerator. Heptio's products improve the overall experience and reduce the cost and complexity of running Kubernetes and related technologies in production environments. They build products, they build open source tools, and they provide training and services and support that bring people closer to upstream Kubernetes. You can find out how Heptio can make Kubernetes easier at heptio.com/sedaily. Joe Beda and Craig McCluskey, who are the founders of Heptio, have both been on Software Engineering Daily, and they were fantastic when they came on. They were really fluent in what is going on in the Kubernetes ecosystem because they helped build it. So to find out more about the company that they're building with Heptio and to find training and resources and products built for Kubernetes, go to heptio.com/sedaily. And thanks to Heptio for being a sponsor of Software Engineering Daily. I'm really proud to have the company on board. Okay, maybe I misread something, or I read a outdated blog post. I thought there was some kind of main buffering system that Kafka was playing a role as, but I guess you don't have really a main buffering system. Like, you don't have an event, a central event log for all of the applets that are getting triggered.
Not in sort of like the critical path of applet execution. Sort of, if you were to look at the output of like our applet runtime that ends up being used for analytics, you would see that data. But today it's structured around this sort of like one-to-one mapping between, or one-to-many mapping, I guess, between like an individual trigger check and actions being run.
So another piece of the architecture that I thought I read about, at least, was GraphQL. Are you using GraphQL?
Definitely. We use GraphQL really heavily to power our client experiences. So the entire data model is exposed via GraphQL, and that is used by our mobile apps and our web front end to build really rich interfaces.
Tell me more about that.
It's certainly a newer piece of our architecture. About a year ago, maybe a little bit more, we went through sort of like a UI overhaul. This is when we introduced the concept of applets. And part of that was trying to bring a little bit more consistency between the web and mobile experiences. And to do so, we wanted to have like a more consistent interface between them. Like so many web applications, we were, calling directly into the database to render pages, and our mobile apps had to use REST APIs. And there was a lot that worked really well about that, but it made it difficult to always keep those experiences in sync. So we made a bet on GraphQL that we could use that as sort of like the lingua franca between our different front ends. And that has worked out really, really well for us. And it allowed us to decouple sort of the data model itself, or like where that data is persisted, things like that, from our ability to effectively use it on our web properties, our mobile properties, and we even use it internally for some of our like monitoring systems and things like that.
So people set up recipes on the mobile apps, and GraphQL is the linkage between the mobile apps and the backend. Is that right?
Yeah, I mean, I think that like for folks who aren't familiar with GraphQL, you can just sort of imagine it as like your typical REST API. The big difference being that the client is able to make very specific queries about the data that it's looking for and the relationships between those pieces of data. So, on the mobile app, you might be requesting information about the applet. And in the mobile UI, you want to, in the same view that you have like the title and the description of the applet, you also want to show the number of times this applet has been run for a given user. And on the website, we might not want to do that. I'm totally making all of this up, but sort of as like an example, if the call to get the call to get the number of times an applet has been run is expensive, we don't want to be doing that on the web if we don't need to, if it's not like being shown to the user providing any value. So using GraphQL, we're able to really precisely target the exact amount of data that we want without being wasteful, without downloading extra bytes over the wire, without making database calls or external calls that might not be important for a given transaction.
Okay. Well, I want to break down in more detail the process of setting up an applet and servicing an applet request. And I think we should figure out a different example, because I think some people, the Twitter Instagram thing is a very familiar recipe for me, or an applet for me, but I think there are probably some people who are listening who do not use either of these services, so they have no idea what we're talking about. Would maybe the Domino's plus Philips Hue light bulb example be better, where let's say I order a pizza on Domino's, and let's say I live in a giant mansion and I've got all these lights, these Philips Hue connected light bulbs that are lining the walkway to my door, and I want to have an applet that makes it so that whenever my pizza is ready from Domino's, it's going to turn on all the lights in my walkway, because the Domino's is right around the corner from my palatial house, and I want the lights to be turned on whenever the Domino's delivery guy comes by. And so I want this recipe to be able to, this applet to be able to connect Domino's to my Philips Hue connected light bulbs, and Ifft is going to be the service that brokers that. First of all, is that a reasonable example for us to explore?
It's a really exciting picture that you painted. I just want to call out that for people who are listening, there's a lot of value in these integrations, even if you don't have this amazing palatial mansion. People who just have a light on their front porch might find it valuable too. But yeah, for sure, I'm totally on board with this one.
Okay, great. Then, first of all, when I set up that integration, what is happening on Ifft's servers?
Sure. So I think that this is such a common use case. Domino's thought of this when they were building their service. They want people to be able to be ready to get their pizza. They want their delivery people to be able to see that there are steps leading up to your door, whatever it might be. So Domino's has published an applet that says, turn on my porch lights when my pizza is out for delivery. And as a user, you are, if you're on Iff.com or using our mobile apps and looking at the things that you can either do with Domino's or with your Philips Hue bulbs, you might see this applet. And it should be as simple as turning on the applet. Like literally it's a switch that you slide and it's on. The configuration depends a little bit on the amount of sort of customizability the author of that applet intends for you, the user, to have. So in this specific case, there's no need for you to customize anything about your, like the Domino's configuration. Like a pizza that's out for delivery is a pizza that's out for delivery. But you might want to have the option to specify which light bulbs do you want to have turn on. So as part of turning on this applet and configuring it, the user is presented with a list of their light bulbs. And you would choose the porch light as opposed to your bathroom light. Or, you could choose both, I guess, depending on your use case. So once you have made that, like configured the applet to your taste and make sure that it makes sense to you, the next time that a pizza is out for delivery, that functionality will automatically, or that experience will happen for you.
Mm-hmm. And on Ifft servers, there's just a polling process that's listening for the Domino's event, or Domino's is notifying Ifft in real time?
In this case, I just know this. Domino's does use our real-time system. So within seconds of the order being out for delivery, or at least that being represented in the Domino's system, your porch light should turn on.
And that's because Domino's has some user ID that they associate with my order, and so that they can publish that real-time event and Ifft can listen for it.
Exactly.
Okay. And once that hits Ifft's servers, I guess you can process the event and propagate it to the Philips Hue light bulbs, and voila. And I guess your lights are turned on. Maybe you can talk a little bit about the software infrastructure that is powering the connection of those APIs, kind of your server infrastructure and how it scales up and down and whatnot. And then we can talk about some of the data infrastructure that allows for analytics on top of that. But I would like to understand just the runtime infrastructure first.
Definitely. So our entire infrastructure today is on AWS. We've been there for years and are generally, I think as happy as one can be with a cloud. We're a little bit unique in that for all intents and purposes, our entire workload runs on an AWS service called EC2 Spot. And what that allows you to do is sort of like bid on excess capacity, excess EC2 capacity, and acquire servers for sort of a limited amount of time at a really reduced rate. And to support having, I guess like the risk there is that your servers may come and go relatively quickly. To support our infrastructure being able to handle like servers coming in and out of commission, we use Apache Mesos to manage how our individual server tasks, like application instances, are deployed and run. So we have a large fleet of these Mesos nodes that are just effectively sitting there waiting for work to be given to them. And they'll run the work that's been distributed by Mesos until the task goes away. And this is across all of our application infrastructure, both our back-end and our front-end experiences. I think that one of the sort of misconceptions around Spot is that you're like never going to have an instance for more than an hour. In our experience, we have Spot instances that stay online for weeks at a time, and we're paying like 20% the sort of like on-demand price for those instances. So it makes a lot of sense for us. Then on top of that, like our sort of like application mesh, on top of Mesos, we use Apache, or I guess Marathon. I don't know who owns it anymore. It's Mesosphere. It's like an application scheduler. And if you're familiar with something like Heroku, it's very similar. There's like a list of applications that are running. You can configure them with environment variables. You can scale them up and down. A little bit less like fully featured than something like a Heroku, but it's a pretty familiar analogy for a lot of folks. So we have dozens of applications that are running, and then across those applications, thousands and thousands of individual application instances that are being managed by Marathon and Mesos. And then for things like periodic background work, we use another framework on top of Mesos called Kronos Cron. So if you have like something that needs to run every hour, Kronos is a really good tool for that. The individual, like our deployment artifact, is a Docker image or Docker container, I guess. So again, all of our applications across the infrastructure run in Docker containers. We have a CI/CD pipeline built on top of Jenkins that will run any tests for a given application as pull requests are made and then pulled or merged into master. And then our developers have command line access to tools that allow them to tag an individual commit for a deploy. And that goes through sort of a similar process of making sure that that commit has been tested, that once that build is green from the testing perspective, we publish a Docker image and then give that configuration information to Marathon and Kronos, and then those tasks are deployed.
When I think about how I would build the Ifft infrastructure today, if we were building it from scratch, the first thing that would come to mind would be serverless, AWS Lambda or Google Cloud Functions, because the call to a recipe seems like a stateless, one-time, spin it up and then spin it down type of event where you can get the functionality you need even from the extremely low-cost infrastructure of an AWS Lambda. Maybe you can tell me if that's true and whether or not you see that as a promising application of AWS Lambda for Ifft maybe in the future.
We do use Lambda internally for a couple different things. Most notably, we now allow you to, as a power user effectively, to write a little bit of JavaScript code that sits in between a trigger and an action in an applet. So you can do things like, in our Domino's to Philips Hue example, check to see if the time of day in the user's time zone is like, I don't know, in the middle of the day. If it is, we don't need to turn on the light. Something like that, right? So we use Amazon Lambda to execute that JavaScript code that our users have provided to us as just sort of like a really simple way to sandbox against anything either intentionally malicious or just like accidentally, wasteful in terms of computation or whatever it might be. I think that there are a couple places where it certainly could make sense to think about serverless in an Ifft architecture in the future. I think sort of a lot of people's mental model, and certainly one that's attractive to us too, is this idea that like we just have this constant stream of data coming from the internet and it hits something like a Kafka or a Kinesis. And then from that, we just execute Lambda functions or serverless functions against that stream of data.
Yeah.
I think that one of the challenges is that like the reality of the internet today is that the real-time story just like isn't there for that to be the only way for us to get data. So we need to have it. I mean, the vast majority of the events that come into our system today are coming in through polling. The good news is that's changing. Like as time goes on, proportionally more events come in through real time, and eventually we'll get to the point where real time is sort of dominant. But until then, like we need to invest heavily in infrastructure that allows us to do this constant polling. And then sort of from like a practical perspective, I think that you trade off a lot with Lambda in terms of your ability to have like certain types of instrumentation and introspectability. Things like the cold start time can really matter for us. You could imagine that the difference between telling your Alexa to turn on your lights, if that happens in, 1 second because that action hit a Lambda that was warm versus 3 seconds because it hit a Lambda that was cold, that sort of like difference in sort of your perception of the product can really add up. There are obviously a lot of places where the timeliness matters less, right? If you're appending a line to an Evernote note, most people aren't like staring at their phone waiting for that line to show up. But there are a lot of sort of more IoT or, interactive use cases where latency is like super, super important for us. The other thing is that the sort of cost benefit of Lambda, I think, depends a lot on there being really sort of like periodic load on those functions. So if you have like a Lambda function that's executing effectively 24/7, the cost of Lambda is going to be higher than EC2 and certainly higher than like a reserved instance or something like Spot. So having like your full workload on Lambda for something like this, where you have like a really pretty steady state of transactions that are happening, you might not come out ahead on a cost basis. There are other benefits too, like, it's less stuff that you're managing actively. So I think it's a lot of trade-offs that, I think a lot of people are sort of digging through. And I'm frankly, super excited about all the work that's happening in that space. And I think that it will continue to mature as a set of products. And, very well in the future, it may be sort of the only sensible way to build internet services, because the expertise and the sort of all the extra work that has to go into actually running servers, it kind of gets abstracted away in a really powerful way by Lambda. And we just need to make sure that the tooling is there, the costs make sense, things like that.
You are programming a new service for your users, or you are hacking on a side project. Whatever you're building, you need to send email. And for sending email, developers use Sendgrid. Sendgrid is the API for email, trusted by developers. Send transactional emails through the Sendgrid API. Build marketing campaigns with a beautiful interface for crafting the perfect email. Sendgrid is trusted by Uber, Airbnb, and Spotify, but anyone can start for free and send 40,000 emails in their first month. After the first month, you can send 100 emails per day for free. Just go to sendgrid.com/sedaily to get started. Your email is important. Make sure it gets delivered properly with Sendgrid, a leading email platform. Get started with 40,000 emails your first month at sendgrid.com/sedaily. That's sendgrid.com/sedaily. The show that we did a while ago about this startup where they solved a lot of their problems with burstiness in traffic by using AWS Lambda, that is not the problem that you have at Ifft, because all day long you need to be polling these services, because you need to be listening to a service like Twitter where they don't have some sidecar process that's running that's saying, oh, we're listening for events that we need to send to Ifft. You need to listen to Twitter, and the only way to listen to it is to constantly poll for the information. Like if you've got 100 different users who have 100 different applets that they've instantiated where they're using Twitter as, something that they're plugging into, you need to be pinging Twitter all the time on looking at those users' accounts to see what they're tweeting so that you can make calls to your own internal infrastructure. And because you've got this constant need to be scheduling polling requests to all kinds of different websites and APIs, you might as well just have full-fledged servers up on a regular basis rather than going through the process of spinning up Lambda and spinning down Lambda containers and dealing with the cold start problem all the time, the latency, and then just the issues from that startup, the costs of starting up and spinning down machines. You're not going to incur that if you're just requesting EC2 instances and having them just be long running, because you're doing polling all the time. So
I think
interesting.
That's totally spot on. I would add that even if we just look at the data that comes through our real-time infrastructure, sort of like the stuff that would be, or the events that would be a perfect use case for something like Lambda, because we have users all over the world, there aren't sort of what you would expect to see as periodic changes in our throughput. We are surprisingly constant in terms of the amount of work that we're doing, which in some ways is really good because it means that we're not being wasteful with our infrastructure by and large. But it also means that the ability to do smart scheduling around what compute resources do you have available at a given time, there just really aren't that many opportunities for us to do that today. So it's kind of nice to not have a problem to solve, but it's also kind of a bummer because there aren't forces pushing us to try out some of these more novel approaches.
How important is cost controls? Are your unit economics good enough that you can have a pretty laissez-faire approach to pouring money into cloud services, or do you have to make certain build versus buy decisions?
It's a really good question. I think that for us, like we've gotten to a point where things like services like our outbound email service and our outbound SMS service account for maybe not an equal amount, but certainly like approaching equal to our monthly cloud spend. So in terms of like our ability to like reduce our total cost, there are these things that are sort of just like baseline expensive because, you know, we were not going to operate telephony services. I think that generally speaking, we do try to be like very sensitive around our infrastructure costs though. About a year and a half ago, we went through a pretty intense process of trying to cut costs where possible, thinking about ways to optimize our services, thinking about things like the data that we're storing on S3. Are we storing that in ways that make sense? Like, are we storing data that we're never going to retrieve again? Are we storing it compressed? Like, what are the access patterns, et cetera, et cetera? We also had a bunch of services running on Heroku because like the deployment and like management story was so simple, and we had a bunch of users who were like used to it and like, okay, like at a certain point that made a lot of sense for us. And then when we had invested enough in our Mesos infrastructure, the sort of incremental cost of running an individual container or an individual application was like approaching basically zero. So we were able to fold a lot of those or consolidate a lot of that sort of disparate compute into a single place where we have a lot more control over like the macro view of cost. And that's helped a lot. The really dirty secret about Ifft is that our runtime is all written in Ruby. So what that means is blocking I/O, which is just like absolute insanity if you think about what Ifft has to do, which is make API calls all over the internet, and it's all we do. We just do I/O. So we are like, in an absolute sense, like being super wasteful with our compute, and that's something that we're actively working to change. So, you know, the goal is to move to a different type of runtime that allows us to do non-blocking I/O. And that I think is going to have a tremendous impact on our like bottom line cost basis.
Are you thinking Go or Rust or Node?
Our sort of inclination right now is to the JVM, primarily because of library support. As heavy AWS users, like the Java APIs tend to be sort of the top tier, or SDKs tend to be the best on the JVM. And there are a lot of like really cool things that you can do on the JVM. We have some folks who are comfortable with Java. We have some folks who are comfortable with Scala. So you have some opportunity to actually like have different experiences, but still have those core sets of APIs and SDKs being really, really solid.
Now, I don't know how much you can go into this or if you're even familiar with it, but just the whole economics discussion of running a business like Ifft fascinates me. And you mentioned something very interesting, which is that the email service and the email and SMS hooks into. So I guess that's basically like, if Domino's sends me a pizza, I want to send an email to my mom and tell her, I wish I was eating your home cooked food. I'm ordering pizza right now. That kind of service. So like that kind of service is accounting for a large percentage of that's accounting for maybe 50% of your cloud revenue, and then a similar service for your cloud costs, and a similar service on SMS is accounting for, another 50% or 40 and 60, but basically those net out to the cost of your cloud services. But I'm actually curious about the overall economics of the business, like how operationally intensive, for example, is your cloud service? Do you have a bunch of ops people that have to be on call all the time, or is it more of a no ops type of system? And how much of the cost of the overall business are headcount? Just like when you look at the macro of the overall business, is it working, and what needs to change to make it work? Or are there certain tailwinds in internet usage trends that are going to make Ifft an extremely profitable business in the near future? Maybe you could tell me about the economics near term and longer term and how that impacts engineering decisions.
Sure. I mean, frankly, I have fairly limited visibility into like our overall like cost structure, but things like headcount, obviously, I have like pretty good visibility into. Our engineering team is really pretty small. It's about 15 folks. Our infrastructure team is 2. So we've done
That's great.
like a lot of work to make sure that we are able to sort of operationalize things in a way where, you need to have the minimum amount of human intervention. And that's been really difficult, but also really rewarding.
Yeah, that's discipline. I gotta say, that's really disciplined, because Ifft has been around for a while, and to keep the engineering team at 17, that's very disciplined.
Yeah, and we're obviously still trying to grow, but we're not at a point where it makes a lot of sense for us to double or triple or 10x the size of our engineering team to solve some of these problems yet. I think that, frankly, we still have a lot of opportunity to, further optimize the way that we are applying our engineers to some of these problems. In terms of sort of like our overall business model and strategy, as it stands today, obviously we're still a startup, if an old one. So, these things are subject to change. But we don't have any interest in charging our users for access to the service. What we do is we charge partners who integrate with Ifft basically like a yearly license fee. So at the very minimum, you have to pay, can't recall offhand, I think it's like $200 a month to be a published partner on our platform. And then from there, we offer sort of incremental services, whether that's like white glove handling of your building a service. We offer professional services, we offer marketing, etc. So, the ability for someone to have like a very light engagement with us or really go deep in terms of how embedded they want that experience to be.
It's so interesting thinking about how Ifft, the prospects for the future, because you can imagine two almost equally plausible futures where Ifft becomes super important or gets obviated by Google or Amazon or somebody else, or just the relationships between the giants changing. So, for example, if Google and Amazon and Instacart all made it easier to plug directly into each other, and Google's got their IoT platform and their Google Voice Assistant and stuff, and they just make it more open, then everything would be copacetic. You could just wire your Google Home into your Amazon Alexa and your Instacart, and they would just ignore their competitive frictions and play nicer together. But you look at somebody like Andy Rubin, who with Essential is trying to make a hub that connects these different businesses that have competitive frictions, because the competitive frictions between them end up being frictions for the user. And so somebody like Essential tries to bridge the gap between those different companies. I see Ifft as like a middleware that is kind of doing the same sort of thing, that takes the same approach as Andy Rubin with Essential, and saying let's make a way to bridge these services together in a way that is agnostic of their competitive frictions. I don't know. Are these similar thoughts as to what goes through your head?
Oh, absolutely. I think that we have long seen the value in us remaining as much as possible a neutral party in sort of this sort of online landscape. I think that in the situation where Google and Amazon and Instacart and whoever, the giants, as you say, they get together and they say that they're going to be cooperative in terms of their integrations and their APIs, etc. In a lot of ways, that would solve a number of problems. I think that another place where Ifft provides a lot of value is putting smaller companies, smaller services, smaller products on an equal footing. So, this is more like my personal take than necessarily the company view. But if all that happened was that Google, Amazon, Apple, whoever decided that they were going to work together and have those products work really well together, it's kind of a net loss, because it really closes the door on a lot of interesting innovation that might happen at a smaller scale. So I would really be bummed if, there were less interesting IoT products or cool social services launching on a regular basis, because there was this much larger walled garden that served a lot of users pretty well, but doesn't necessarily solve all the use cases.
Okay. Well, we jumped to the business section of my preparation. Let's scale back. I know we've only got 10 minutes or so left, but I want to go through the rest of the infrastructure, or at least some of it. So we've kind of talked end to end about how a request from Domino's is going to translate to my Philips Hue light bulbs being turned on. we talked about the server infrastructure that manages that contract between my different services that are bound together by an applet. Let's quickly run through monitoring and data infrastructure so that we know how you are able to have visibility into this system and the analytics that come out of it.
Sure. So I think that there are sort of three flavors of monitoring, visibilities, introspection, however you might want to think about it. We use typical APM tools like New Relic for our sort of like edge applications, whether that's like our APIs or our web servers, things like that. Pretty familiar, I think, for most listeners. We also use your typical sort of like StatsD compatible time series visualizations. We use InfluxDB and Grafana to sort of do aggregates and visualizations on more like application specific metrics and infrastructure level metrics as well. So things like percent utilization of CPU across the cluster or E99 transaction time for a specific request hitting our load balancer. And then from the Ifft runtime side of things, we have really verbose, like rich output that goes to our, like the final destination is our analytics pipeline, but we tap into that to throw it into Elasticsearch, and we do like regular aggregations and visualizations on top of that data as well to get a sense of changes in behavior, being able to look at things like changes in like service time by individual service that we integrate with, things like that.
And as I was reading about the data infrastructure, I read about some things like Elasticsearch, Apache Spark, some sections of the infrastructure where data goes in batches, other places where it streams. Talk about some of the tools that you use in your data infrastructure.
Yeah. So the very end of it, like our two sort of final repositories for data are S3 and Redshift. And Redshift is sort of like the thing that most people are using to run queries against our data on a regular basis, whether that's engineering, trying to gather insights into like how people are using the product, or our marketing team trying to do cross-sections on users and behaviors and things like that. Our data pipeline is a mix of streaming and batch using Spark for streaming and then AWS data pipelines for batch loading, doing things like taking nightly snapshots of some of the tables in our production database and copying them into Redshift. We also have some more specialized data products that sit on top of our streaming tools like Amazon Kinesis to do things like predictive modeling for how often we should be polling an API on an applet by applet basis, things like that.
So when I worked at Amazon and also just hearing other people in the industry talk about what it's like to be on call at AWS, it sounds really hard. And Ifft is kind of an infrastructure provider. There are people who have built fundamental components of their business that sit on Ifft, I assume. What's the ops strategy at Ifft? How, what kind of SLAs do you try to have, and how sensitive do you feel like the infrastructure is?
That's a really good kind of nuanced question, I think. In general, we treat our systems as critical, right? Like we don't understand the specific use cases that any of our partners or users are using Ifft for, so we kind of have to assume that they're all really, really important. I know that like one of the really inspiring uses of Ifft is someone built an integration that allowed them to sort of do passive insulin monitoring for someone in their family. Ifft isn't actually like
passive what?
Like blood sugar level monitoring.
Oh, insulin monitoring. Okay.
Ifft isn't sort of responsible for providing like dosing, but reminder is that like, hey, you should probably have a little insulin. So, things like that. It's like, well, we really need to have our systems performing reliably and in a fast performant way. Really important use cases. So I think that like at a fundamental level, it's about the same sort of like engineering discipline that lets us get away with having such a small team, making sure that the systems that we build are robust. And when things go wrong, we know as soon as possible, making sure that we have the right metrics in place to understand like what types of issues are problematic, things like that, as well as having systems that are relatively adaptable at sort of routing around different types of problems. So when Twitter's API goes down, or like, I don't know, Domino's API gets slow for whatever reason, we have protections in place to make sure that that doesn't have downstream effects across all of our users, all of the integrations, to make sure that things that continue to work really well. One of the sort of like facts of running a business that is connecting all parts of the internet is that something's always broken. Sometimes it's our stuff, but oftentimes, just like by the law of numbers, it's someone else's integration that's going through problems. So we provide our partners with in-depth analytics around their integrations. We have alerts that they can subscribe to know if there are issues with their APIs, things like that. And then we have pretty well-defined roles for different people who are on call. So our infrastructure team is responsible for the base infrastructure, anything that's sort of like at the control plane or load balancing level, they're on top of. We have a team that's on call for the Ifft runtime, making sure that the systems like the thing that enqueues checks for applets is running, and that we have enough capacity to execute all of the applets in an expedient way. And then our web team is on call for things like the website being down or reaching a critical level of errors. And that really allows the people who receive a page to be, able to act on it pretty immediately because it's a system that they're intimately familiar with. And it also creates positive feedback cycles. So like if you get woken up because of an issue in the code that you deployed earlier or that you had a hand in creating, you're much more empowered to go in and like understand what that was, figure out how to make a change, and help yourself not be alerted by that in the future.
All right. Well, this has been a really interesting conversation, Nicky. Maybe you could close off. Tell us what Ifft is working on right now, maybe some of the big engineering challenges that you personally are focused on.
So I think that my focus at Ifft is on the runtime, and as a team, we are really focused on what I hinted at earlier, moving our like core Ruby runtime to something more performant, probably on the JVM.
What kind of cost savings are you going to get out of that?
It's really difficult to say. I would guess like for our part of the system, probably on the order of like 10 to 20x.
Yeah. But
it's like, it's hard. It's easy to be like really optimistic about that. It's also hard to underestimate the total cost of blocking I/O again in like a system like ours. Sort of like depending on how we're measuring it, like we are at sort of like 90 to 99% idle at any given time. So there's a lot of opportunity to make some big improvements there.
All right.
Yeah, that's it.
Cool. Anything else you want to add?
I don't know. We're hiring. So if folks are in the San Francisco Bay Area interested in any of the projects that we're working on, whether it's our runtime, our infrastructure, our data products, our mobile apps, our web products, we'd love to talk to you.
All right. And you can send Nicky an email, perhaps, or send me an email. I'll connect you to Nicky. Or you can probably find him on Twitter. I assume you're on Twitter.
I am.
All right. Great. Cool. Well, this has been a great conversation. Thanks for coming on the show.
Thanks, Jeff. It was great.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!